All right. We'll hope others join us. Want to start with just a quick review of last night. I want to remind everybody that PDF quiz is due Sunday night by 11:59. Very simple. Download an app to your smartphone, unless you already have one, or unless you have another way. Like a lot of people have an all-in-one printer at home that does their scanning for them. That's cool. Whatever. I don't care how you scan it in, just as long as you scan in one file or one document, but it has to be 3 pages long. And it's got to be all that stuff about it. One page has to be a page from the book. Next page has to be some kind of silly drawing that you do. It could be as dumb as a stick drawing, or it could be something intricate. Third page is something handwritten, maybe a math problem that you do, maybe a poem, maybe a limerick, maybe some message that's important to you, or a message that's not important to you. Okay, but just 3 pages long with something on each one. Thank you. Now, last night, okay, we introduced circles, among other things. So okay, what I want you to do is graph this and label the center and what I called news. Top, bottom, left, right, relative to the center, wherever the center is. In order to do that, you're going to have to check your notes, use completing the square to put this into standard form. Okay, so take a second and do that. I thought I turned it on. Apparently I didn't. Okay, so take a second. Okay, I'm going to put it in standard form, but I'm going to pause this again while you go ahead and attempt to graph it after we put it into standard form. So to put it into standard form, we reorganize the problem. X squared minus 8x plus blank plus y squared minus 12y plus blank equals -3. So we lump the x's with the x's, leaving space for the magic number. Lump the y's with the y's, leaving space for a magic number, and just move the 3 to the other side by subtracting 3 from both sides. Then the process we use was called completing the square. And to do that, you take half of the b value, which is the number in front of the single variable x. Half times 8 is -4, but then you square it and you get 16. So you add 16 to this side over here. Then you complete the square on the y's. You do the same thing. Half times -12, whoops, is -6, but then you square it and get 36. So you add 36 to the other side of the equation. Then what happens is this quantity factors, and it factors using that number. So this quantity will become x minus 4 quantity squared. Okay, plus we factor this quantity. Okay, again, it will factor using that number. So that will become y minus 6 quantity squared. Okay, equals, okay, add that up. That's, I believe, 49. 36, that's 52. Take away 3 is 49. Yeah, I think I've done it right. So instead of 49, we fudge this and we say that this is 7 squared. You could have left it 49, it's fine. But from this, we get that the center of this shape was 4,6. Remember, I spent a lot of time last night talking about students. Basically, you take the opposite when you're taking information from inside a parenthesis like this. You take the opposite of what you see. You see a -6 for the y, you use a +6. You see a -4 with the x, you use a +4. Okay, that's consistent whenever we take information out of a parenthesis like that. And we get the radius is worth 7. Okay, so I'm going to pause again with this information. You should be able to graph this circle, and also, I know I didn't say it earlier, state the domain and range. So graph this circle that's indicated here, state the domain and range. Okay, so with our center at 4, 6, okay, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, something like that. 4, 6. Not drawn to scale, of course. That's the center. Put it there, put its ordered pair. Now, the radius is 7, and I mentioned something like news. News was up and down from the center, north and south from the center. When you go up and down, the x value is staying the same. It's the y value that's changing. So if you go up 7 units, if that was 6, that would be about 7. So this should be 4, 13, because you went up 7. This distance here is 7, and that's what the radius was. Okay, we go down 7, so this should be 4, -1. Again, why? Because we went down 7. And going up and down changes the y value. So 6 plus 7 made 13. 6 minus 7 made -1. Going up and down changes the y, does not change the x. Now we want to go sideways, left and right. So now we're going to change the x value. Still with 7. Okay. So if I go 7 out here somewhere, it'll be like this. This will be 11, 6. Okay, why? Because I went over 7. So 4 on the x plus 7 more, the radius, equals 11, 6. Okay, if I come backwards here, okay, no, that's 7. So it should be here. This should be -3, 6. Okay, again, I came back 7. Okay, now these things I put in red, you don't have to write them down. I'm putting them there. Okay, whoops. Notice how I cheated. You can do the same thing. Okay, I just kind of moved my dot here to make a circle. It looks prettier. So the red plus and minus 7s that I put in there was to show you, the student, what I'm thinking, how I'm using the radius 7 and add and subtract from the center point. Okay, but you don't need to show that at all. Then the domain of this picture is all possible x values. So the domain is going to equal everything from -3 to 11. Bracket. And the range is going to be from the lowest point to highest point. That's everything from -1 to 13. The range represents the y values. And that's it. Okay. We use completed the square to change this from a bizarre format into what was called standard form or graphing form. because it gives us our critical information right away. Then we use that information to help us graph this, labeling the center, and then north, south, east, west. Those points, notice they're ordered pairs. All right, I want to do another problem. I need to erase the board, but I want to see, are there any questions about anything I did up here on this graph, on this problem, and then its graph? No questions. Okay. I need to erase. Is anybody going to yell at me? Okay. To make room, I'm also going to erase this thing. It's a reminder about the Sunday quiz. I talked about it right at the start of class. If you logged in a little bit late, check with me after class or go look at the first 5 minutes of the video of this thing. Tonight's lesson. Yeah.
Professor, what? So I know the PDF quiz, but what is the last page of that one?
Oh, I don't care. It was
okay.
some kind of handwritten poem, handwritten message.
Oh, yeah. It was a poem. Okay.
Just something, just handwrite something. Hi, Foster, whatever like this.
Okay.
Hi, Foster, math sucks. I don't care.
Okay.
Just something handwritten. Okay. All right. Next problem. Four x squared plus 9y squared minus 32x plus 36y plus 64 equals 0. Now, before I pause the recording and let you guys go to work on this, I mentioned last night, and I want to keep hammering this. The top problem, I can tell by looking at it that it's a circle. It's a circle because it's got x squared plus y squared. That's important. That's the key feature, x squared plus y squared. And the coefficients of x squared plus y squared are the same. In this case, they're 1. Okay, so that tells me, it tells everybody, that's a circle. Now, where it is, where it's been moved to, nobody knows until we actually do the completing the square bit. But there's a circle. Now, I explained that a circle and an ellipse are the same thing, except an ellipse has been squished. So this is an ellipse because it's x squared plus y squared. It's the same features, x squared plus y squared, but the coefficients are different. That's how I know it's an ellipse. X squared plus y squared, coefficients the same, it's a circle. X squared plus y squared, coefficients are different, it's an ellipse. Because to us, mathematically, circles and ellipses are almost the same. Okay, so I want to be quiet now, give you a little bit more time. Same stuff. I want you to graph this. You need to find the center. You need to find the radiuses, plural, radii is actually the proper word, okay? And then graph the sucker. Check your notes. This was harder, but I will give you some time to try it. Okay, I want to go through the complete the square process because it's tricky, and I'm certain that most of you did not pick it up last night. There's too many little tiny steps. So I want to go through that. After we get it into standard form, after we maneuver this into standard form, then I'll stop and let you graph it, give domain and range and that kind of junk. So here we go. The first thing we do, again, is rearrange it. So if we have the x squareds with the x squareds, whoops, I can do it correctly. and the y-squareds with the y's. Okay. But one of the problems with completing the square is it doesn't work when the coefficient is more than 1. It was really easy to complete the square up here on this problem, okay, the circle, because the coefficient was 1, so we didn't have to think about it. But down here, the coefficient is not 1, so we're in trouble. So we get out of trouble by factoring a 4 out of all the x's. And factoring a 9.
Sir,
Yeah,
it's supposed to be a 36y.
thank you. That would have been a mess. Thank you. Y squared plus 4y plus blank equals negative 64. Okay, now we can complete the square on the x's. Half times negative 8 is negative 4, but we square it and we get a 16. But we add 64 over here because the 16 is being multiplied by this 4. Okay. Some instructors, instead of just saying put a 16 here and a 64 here, okay, some instructors show their students this. We add 4 times 16 to show that they're adding 4 times the 16, which happens to be 64. Okay, and a lot of students like that because it explains where that 64 came from. 4 times this magic number. Then we move inside here. We take half of the 4, which is 2, square it, which is 4. But that means we add 9 times 4. Okay, 9 times that 4. Now, before I go on, is that okay with everybody? You know, first off, where did I get the 16 and the 4? Secondly, why did I add 4 times the 16 and 9 times the 4? You're going to need to know how to do that. You're going to get confused on the test. So I'd like to get as much clarification out of the way now as possible. That's okay with everybody? Okay. Then this becomes 4 times x minus 4 quantity squared, because we use that number, plus 9 times y plus 2 quantity squared, okay, because that factors, equals, and this becomes 36 when you do all this on your calculator. Or to be lazy, that was positive 64, that was negative 64. So in arithmetic, those cancel each other out. So I'm left with 9 times 4, which is 36. But keep in mind, an ellipse, the form was it must equal 1. Okay, that was one of the forms for an ellipse. It was all this garbage, x minus h, all this nonsense stuff, but it had to equal 1. So to force it to equal 1, we divide everybody by 36. Okay, and then that simplifies to x minus 4 quantity squared over 9, because 4 and 36 reduce to 9, plus y plus 2 quantity squared over 4 equals 1. And that is standard form. Okay. From that, we get the information that the center where's the glare? Okay, the center is 4 comma -2. Remember, pick the opposite. That says -4, we use +4. That says +2, we use -2. And because it's an ellipse, we have something called the x radius, which is the square root of 9, which is 3. And the y radius is the square root of 4, which is 2. Okay. All right. Before I turn you loose and let you finish graphing this and stating domain and range, any questions on my work at all? I'm going to have to erase some of this over here to make room for my sketch.
I have one question, Professor.
Sure.
So you said for the standard notation at the bottom, if we're on the test, if we wrote it like that, or would we have to write 3 squared and 4 squared on the bottom?
No, I would give you full credit for that.
Okay, awesome. Thank you.
Yeah, I mean, yeah, just you correctly realized that this is 3 squared, and that's how we got the 3. This is 2 squared. As long as you use it properly, I'll accept this 100%. Okay.
Awesome. Thank you.
Yep. Anybody else? Any other questions? Okay, I'm going to pause the recording. Okay, so where's my center? So there's my center. I have to think a little bit more analytically now. My x radius means from the center, I go over 3 and backwards 3. That's what x radius means. So from the center, if I go forward 3, I get 7 comma -2. And if I come backwards 3, I get 1 comma -2. Okay, that's not drawn very close to scale, but good enough. Okay. So what I did, again, for your notes, is I went forward 3, backwards 3, because that's what my x radius says, and x always runs horizontally, sideways. My y radius is 2, which means I'm going to go up 2 and down 2. If I go up 2, I'll be at 4 comma 0. If I go down 2, I'll be at 4 comma -4. Again, I'm going up and down 2. Oops, 2, -2. Those red things are really messing it up, make it messy, but, and remember, this is as smooth a curve as you can draw. And we'll cheat because we want it to look like a pretty ellipse. So I erase my dot, and there it is. There's my ellipse. Okay. Yours, well, first off, most of you can draw better than me. Okay. I don't need to see your work. I just know I'm a terrible quote artist, unquote. Okay. Sure looks like a circle to me. That's why it's important that you put those ordered pairs there, because no matter how bad your drawing is, within reason, okay, I'm going to pay attention to those ordered pairs. That's what tells me you know what you're doing. Okay, and those are the news. There's the center, 4 comma -2, and then I have north, south, east, west, or whatever. I don't know which way is east and west. My domain is x's. They range from 1 up to 7. Those are my x's. My range goes from the lowest y is -4, the highest y is 0, and that would be my range. And that's everything. Okay. Questions on this before I erase and get off into totally new stuff tonight? Any questions, anything, any clarification? Okay. In Math 141, which is pre-calculus, they will revisit circles and ellipses and even hyperbolas and parabolas and everything we do, and they will talk about much more detail. Much more. But as long as you have these basics, you're going to be fine. Okay. You won't be lost. Remember, I said there's something called the foci, or sometimes pronounced foci, F-O-C-I, on the longer axes. In this case, the X radius is the longer. It's called the major axis because it's longer. Okay. And there's some of these magic points called the foci on them. If you watch that video, okay, I believe the guy showed you how to draw an ellipse using the focal points or the foci. Okay, last chance to ask me questions before I erase all this. Okay. Quickie review. Way back in chapter 9, we studied the quadratic equation. Okay, it was basically ax squared plus bx plus c equals 0. Okay, it was an equation that equals 0. And then we talked about all kinds of ways that we could solve it. We could solve it by factoring. We could solve it by something called the square root principle. We could solve it by the quad formula. And we may have talked about some other stuff, but that was called a quadratic equation, and we concentrated on solving it. Now, for what it's worth, we're going to have to use these again tonight, but in a totally different way. But I wanted to talk about that. If you take the same problem, okay, this is chapter 11, and instead of making it equal 0, make it equal y. Y equals ax squared plus bx plus c. So instead of equaling 0, that made it a quadratic equation. This is called a quadratic function, F-U-N-C-T-I-O-N. Okay, it's called a quadratic function. Sometimes in place of y, we get fancy and we try to scare you and write f of x equals. Well, f of x is the same as y. So f of x equals, y equals, it doesn't matter, they're all the same. The key is this is quadratic function. If we graph this, okay, it's called a parabola. And essentially a parabola is a U-shaped curve that either goes up or down. Now it's more than that. Tonight, I'll come back and revise that a little bit, but right now, I don't want you to get lost. So we're taking, the focus of this is we're going to take a bunch of equations that look like this, y equals ax squared plus bx plus c, And we're going to try and graph it. And all of our graphs will be in a parabolic shape, a parabola. They'll either be up U or down U. Okay. Now, some things that help us here. First, okay, if A is, I'm going to do it this way. If it's a positive A, then the shape is up. The graph is going up. If it's a negative A, then the graph is down. Okay, it's that simple. There is a new formula you need to know. Okay, and it's for something called the vertex. The vertex is this little point either at the very bottom or at the very top of the curve. If it's going up, this is the vertex, and it's called the minimum because it's min, we abbreviate it, okay? Because the vertex is either the lowest point or the highest point on the curve, okay? If the curve is going up, then the vertex is the lowest point. If the curve is going down, then this is still called the vertex, okay? But now it's called a max. It's the highest point. Okay, so that's called the vertex. To find the vertex, there's two techniques. Okay, that's what's going to make tonight hard. Okay, because you're going to have to learn both techniques. To find the vertex, you use this formula, negative b over 2a, comma, plug it in. To find the vertex, you use negative b over 2a, comma, plug it in. Now, that negative b over 2a shouldn't be any great shock to you. Recall the quadratic formula. I'm going to write it up here and then I'm going to erase it. But the quad formula okay, was negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Or if you take it apart, it was negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So the front part of the quadratic formula tells us the x value. Remember, an ordered pair is an x comma y. So this formula here, which you need to know, that should be something that goes on your note card. Vertex of a parabola, negative b over 2a. Okay, the x value is found just simply by plugging into this formula. The y value is found by taking this x and plugging it into the equation. Now I'm going to do a problem for us. Okay. Anybody have any questions before I start doing a problem? Okay. So I want us to graph and label a whole bunch of stuff. Okay. And instead of writing it down now, I'm going to graph the problem and then show you what I want you to label. Okay. So let's take an example. Y equals 2x squared plus 8x minus 3. Okay. So I want to graph that without going to Desmos. Now you can go to Desmos when you're trying homework and check your own work out, okay, and make sure you're doing it right. But you're not going to have Desmos available to you when it comes to the chapter 11 or exam number 4. You're just not going to have that. So you got to know how to do it by hand. So here we go. First off, I see that A is positive 2. Remember, A is the number in front of the x squared, B is the number in front of x, the coefficient of x, and C is called the constant. That's the number without an x. So because A is positive 2, this tells me that whatever my shape is, it's going up. Okay, that's what I wrote here. If it's a positive A, it's going up. If it's a negative A, it's going down. Okay. My vertex is found by using negative B over 2A, comma, plug. So I use negative B. In this case, it's going to be negative 8, negative B over 2 times 2, comma, question mark. So that's negative 8 over 4, that's negative 2. Now, negative 2 what? Plug it in here. So you're going to go 2 times negative 2 squared plus 8 times negative 2 minus 3. And this is where your calculator or your arithmetic is going to really screw you up. First off, PEMDAS says we have to square this first. Negative 2 to the second power is positive 4. So this is 2 times positive 4 plus negative 16 minus 3, 8 minus 16 minus 3, negative 8, I get negative 11. Now, this is my work. This is my answer to my work. I don't care if you show me this work or not, but you do have to show me that. That's the vertex. This you can do all on your calculator. Okay, so I don't need to see it on your paper, but you do need to show me that that's the vertex. So a lot of students get lost in my work. First, I calculated the A value, so it told me where it's going, up. Okay. Second, I calculated the vertex, negative B over 2A, plugged it in, got negative 2. What do I do with the negative 2? I plug that into my formula in place of x. Remember, this is the ordered pair, x comma y. So this is saying x is negative 2, and when I plug it in, I'll figure out what y is. Okay, I want to erase this work here. Is that okay with everybody? Do you understand where I got the negative 2 from and where I got the negative 11 from? Okay. Now, we can do a pretty reasonable sketch right now. And it's going to get kind of messy, so hang with me here. Okay. Negative 2, negative 11. Guys, I don't care if it's drawn to scale perfectly or not, but this is the vertex V, and it's negative 2 comma negative 11. And it's going up.
Professor, that one should be positive 2, negative 11, because you draw on the on the right.
Yes, damn it. Yes, you're right. Thank you. Thank you. Okay, -2, -11. Okay, better. Thank you. Now, right now, we don't have any way of telling. We know it goes up, but some of you are going to draw it fat up. Some of you are going to draw it skinny up because you have no basis for telling. Is it fat and going up, wider and going up? Is it skinnier and going up? What's it doing? So we need another point. And that other point to help us is the y-intercept. Because that's the easiest thing to find. To find the y-intercept, remember that always means x equals 0. Okay? To find the y-intercept, you set x equals 0. Now, we were doing this way back in chapter 3 when we were looking at straight lines, or chapter 2, rather, when we were doing straight lines to find the y-intercept. So you plug that in, and you get y equals 2 times 0 squared plus 8 times 0 minus 3. You get y equals -3. So our y-intercept is when x was 0, y is -3. Okay. All my pins are dying. Hang on a second. Come on. All right. I need to erase this. So let's see now if I can get a better graph. -2, -11, somewhere down here. This time, notice I learned my lesson. The vertex is -2, -11. My y-intercept is 0, -3, roughly right about there. Fake it. Now, there is, remember I told you I wanted you to label a whole bunch of stuff? Well, here it comes. A whole bunch of stuff. The first thing you need to know is on this parabola, there is something that goes right through the middle of the vertex, and it's called the axis of symmetry. And what that means in plain English is it's a center line where the one side of the parabola matches the other side, and you could fold it along this line and the two sides would match up. Okay, so the right side of this shape and the left side of this shape would be identical to each other. Well, the right side of this shape looks like this. Here's my vertex. It goes up through the axis of symmetry and keeps going up and up and up like that. Okay, now bear with me, guys. Okay, this point is 2 units away from the axis of symmetry. My y-intercept is 2 units away from the axis of symmetry. So its reflection, its image, should also be 2 units away, because the right side and the left side are the same. And that tells me then that the other side of my graph looks like that. Okay. The right side and the left side are identical to each other. They're mirror images of each other over this line, this axis of symmetry. So once you find the y-intercept, you do what's called a reflection. You flip it over the axis of symmetry to find its other point over here. Where is it? I just took it 2 units this way. Technically, it's -4, -3, but I don't really care as long as you're accurate that way. Okay, with those 3 points, the y-intercept, the vertex, and then the reflection of the y-intercept over the axis of symmetry, okay, you've got a really, really accurate graph with minimal work. Yeah, there was some, okay, but very little work in doing this problem. Okay, let's pause and ask questions because I'm going to make it more complicated in a minute. Okay, so on the homework or on the test, I'm going to give you some equation, y equals something, 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 and I'm going to say, graph it. Show me the vertex, the axis of symmetry, the y-intercept, okay? And sometimes I'll ask for the reflection of the y-intercept. That's just taking this and flipping it over the axis of symmetry. It's real simple. Sometimes I'll ask for the x-intercepts, which I'll show you in a moment. Any questions about this? Okay, here we go. The y-intercept was calculated by setting x equal to 0, plugging it in, doing arithmetic. Okay. The x-intercept, so let me get this. The y-intercept turned out to be 0, -3. Okay. If I was really cruel, which I will be, trust me, I could also ask you for the x-intercepts. Where are they? They're here and here. Those are the x-intercepts. That's where the graph crosses the x-axis. Okay, the x-intercepts. But I want to know, what are their numbers? What values are the x-intercepts? Well, if the y-intercept is calculated by letting x equal 0, then the x-intercept should be calculated by letting y equal 0. If you want to find the x-intercept, you set y equals 0. So we have this problem. 0 equals 2x squared plus 8x minus 3. If you want to find the x-intercepts for this problem, okay, this is what you do. Well, now all of a sudden, we're back into chapter 9, okay, where we were solving quadratic equations. And we had a bunch of ways to do that. Does it factor? Can I use the 0 or the square root property? Okay. Do I use the quad formula? That's what you have to decide. This particular one, we're going to use the quad formula. So we get x equals -b, -8, plus or minus the square root of b squared. Well, all right, -8 squared minus 4 times 2 times -3, all over 2 times 2. Yeah, I avoided this glare. So x equals -8 plus or minus something all over 4. what's the something? 64 plus 24. Oh, I don't trust myself. Okay. So this is square root of 88. I think I did that right. 64. Yeah. Okay. Now, I want to show you something. Back in chapter 9, we just kept this as one single fraction. Okay. I'm going to suggest to you okay, what was the square root of 88? Where'd it go? There it is. That you split it up. Notice you always simplify radicals. That should go without saying. Every time you find a radical, you should try to simplify it. And most of your calculators will do it. If not, divide it by 4. This reduces okay. -8/4 reduces to -2 plus or minus. This is radical 22. The 2 and the 4 reduce to this. The reason I like this is because it says, oh, from the -2, remember, this is where our vertex was. From the -2, we go over radical 22. So this point here is -2 plus square root of 22 over 2. So from the center line, the axis of symmetry, we go over the square root of 22 over 2, and we get that x-intercept, whatever that number is. This point is the negative side. From -2, we come back radical 22 over 2. So this is -2 minus radical 22 over 2. That's what those two x-intercepts are. So we'll do another problem. Don't panic. So I won't always ask you for all of this stuff on a single problem. That's too much. Okay. But on one problem, I might say, hey, find the vertex and the x-intercepts. Another problem, I might say, find the vertex and the y-intercepts. Okay. I might, I'm going to mix them all up. But for us learning right now, I'm just dumping everything on you. I'm finding it all. But on the test question, I won't find it all. That's too much on an individual problem. I'll find little pieces of it. So what I did, I asked, can you find the x-intercepts? To find the x-intercepts, you set y equal to 0 and solve whatever problem comes out. So y equals 0, I solve that problem. I use the quad formula. But I said right down here, it would be, in my opinion, it's not required, but in my opinion, it would be nice to separate this fraction as -8/4 plus or minus, okay, I simplified the radical at 88. So 2 radical 22 over 4, then I simplified. The reason I did that is because I wanted to show you that everything is symmetric with respect to that axis of symmetry. So from here, from the -2, if we go over radical 22 over 2, we get that x-intercept. If we go to the right, positive. But from here, if we go backwards, negative radical 22 over 2, we get the other x-intercept. Now, if you really wanted to know what they were in terms of decimals, you can pop those. You could use the FD feature on your calculator and get the decimal equivalent. Okay, maybe we'll do that. Maybe we won't. I don't know. All right, I want to do another problem, but I want to make sure you're reasonably comfortable with all this stuff I just dumped on you. Okay, I don't hear anybody yelling. Either you're blown away or you understand it. Or you're so blown away you don't have any way to ask questions. All right, I need to erase all this so we have room for another problem. Okay, don't hear anybody yelling. So let's take example number 2. And let's go y equals, oh, I don't know, -3x squared minus 12x minus 1 plus 12x plus 10. Let's do it that way. I want this to be nice. Yeah, that'll be good. Okay, so let's start with a graph. At the very least, I want to see the vertex and the y-intercept and its reflection. Over, okay, we abbreviate it, the axis of symmetry, we say AOS. The axis of symmetry was that dotted invisible line that goes through the vertex. So I'll pause the recording right now and let you get as far as you can go, and then I'll stop and we'll work through it. Eventually, I am going to ask you to find the x-intercepts. So you can do that one also, but this is the key right now. So first thing I notice personally is that A is -3, which means this is going down. So my shape had better be going down. If it's not, I screwed up big time. Second thing I do is find the vertex. Okay, the vertex is -b, so it's -12 over 2 times -3, comma, plug it in. So that's 2. -12 divided by -6 is 2. Plug it in. Okay, let's see. -3 times 2 squared plus 12 times 2 plus 10. That's -12 plus 24 plus 10. That's 22. Okay. This is dying. Okay. Next, I want to find the y-intercept, which means x is worth 0. So it gives me y is 3 times 0 squared plus 12 times 0. Yeah, I know some of you are saying, do I have to do all that? No, you don't. So you have 0, 10. Okay. So I'm going to pause the recording again with this information now. Okay. Can you sketch a parabola? It doesn't have to be perfect, but remember its reflection. Okay. I want you to think about that reflection before I actually show it to you. Let's see what we got. Whoa. 2,22. Okay. Remember, I don't give a squat about perfect accuracy. Make it reasonable, make it representative. But I don't want you to count up here 22 little squares. That's silly. Okay, just, it's way high up there. So just make it look way high up there. Okay, if I wanted accuracy, I'd tell you to go to Desmos and copy that graph perfectly. I don't want that. I want you to use your brains and your common sense. Okay, the y-intercept is 0, 10. Well, this is 22. 10 is about halfway. So we're going to go 0, 10. I'm just faking it. All right. The axis of symmetry is the line that goes through the vertex. Okay. Its actual equation is x equals 2. It's a vertical line through the vertex. X equals 2. It's just telling you that. That's its equation. Okay. Now we can reflect this point. How far is this point from the axis of symmetry? It was 2 units away. So its reflection over here should also be 2 units. Okay, so this point over here is 4, 10. I went over 2 and over 2 more. So now I can sketch this. It looks like this. Goes through here, goes down, goes through here, goes down. Okay, pretty good graph. So there's my axis of symmetry and its equation. There's my y-intercept, 0, 10. There's its reflection over the axis of symmetry. And that was just counting on my fingers and toes. I said, you go over 2 to hit the axis, and you go over 2 more to hit that point. Okay, and then the vertex. Questions on that? You're sure? Because I guarantee you between the last question and this question, you're looking at one of these on exam number 4 and on the final exam. I guarantee it. You're going to look at one of these parabolas, okay, where I'm going to ask you, what's the vertex? What's the y-intercept? What's the axis of symmetry? I'm guaranteeing you that's on exam 4 and on the final exam. Okay, then I'll pause the recording in a second. Now I want you to find the x-intercepts. I want you to calculate the x-intercepts. So I'll pause while you check your notes and try it. So to find the x-intercepts, I set y equal to 0, which means I have 0 equals negative 3x squared. I'll move out of the way, plus 12x plus 10. That's what I'm solving. I'm taking this problem, setting y equal to 0, trying to solve that. My own preference, remember, my own idiosyncrasy is I like all of these. I like the x squared to always have a positive coefficient. You don't have to do that. I just find it makes for less mistakes. So personally, I just move everything over here and get 3x squared minus 12x minus 10 equals 0. that tells me my coefficient of x squared is positive, and I just like it. I don't know why. So I quad formula, x is negative b, positive 12, plus or minus the square root 12 squared minus 4 times 3 times negative 10, all divided by 2 times 3. So I have 12 over 6 plus or minus the square root of somebody over 6. I need my calculator. Come on. $264. Come on. So x is 2 plus or minus 2 radical 66 over 6. So this is 2 plus or minus radical 66 over 3. Again, notice I separated, we didn't do this in chapter 9. I separated the answer into 2 fractions because I personally like the idea of showing that the 2 x-intercepts are symmetric over that axis of symmetry. This is 2 plus something, and this one over here is 2 minus something. So for our notes or for our answers, this point is 2 plus radical 66 over 3. And this will be 2 minus radical 66 over 3. Now, if you wanted to keep that as one big ugly fraction, okay, where it would be something like 6 plus or minus radical 66 over 3, and you wrote this as 6 plus radical 66 all divided by 3, and you wrote this as 6 minus radical 66 all divided by 3, okay, so you didn't separate it, I have to give you full credit because your mathematics is right. Okay, I'm just trying to show a relationship here, how everything seems to be revolving around or centered around the axis of symmetry. Okay, I like that form better for parabolas, but this form is still perfect, and if you use it, you must get 100%. Okay, so don't panic too much. Questions on that problem? Okay, 2 things I want to talk about. Can you state the domain and range for this problem? The domain and the range. Okay, take a second, think about it. Domain, range. Okay. We've talked about this before. We've seen this in some cases, but not for quite a while. One of the things you need to know about a parabola is if it starts here at the vertex, it comes down here and it slowly gets wider and wider. Whatever you do, don't do this. When you graph a parabola, don't say, Okay, it comes down here, and then it gets really wide. No, it doesn't. It does not get wide. Eventually, it gets out here, but it gets out here quite slowly. It keeps going down, down, down. Yes, it gets wider, but it doesn't suddenly just zoom out there and get super wide, super fast. Okay, so be careful when you're graphing these. My point is these two arrows keep going down and keep slowly getting wider. Eventually, the domain will either be the fancy R, which is set of all real numbers. Eventually, they'll cover everything, every X value. You can remember, write that, or you can say negative infinity to positive infinity. That's the domain on this shape. It slowly gets wider and wider. Okay. Now the range, be careful, is from 22 down to negative infinity. But we always go from low to high. So the range, okay, would be negative infinity with a parenthesis on it, comma, 22 with a bracket on it. Even though your thought process is, oh, the range is from 22 down, you're right. But we always go from low to high when we write the interval notation. Low on the left, high on the right. So you got to think of the range as from negative infinity up to 22. Okay, is that okay for domain and range?
Yes.
Okay, one thing, and then we're going to take a quickie little break. Okay, because we've covered about 1/3 of what we need to cover. I told you tonight was going to be just messy. Okay. In chapter 10, we talked about the exponential graph. That was y equals like 2 to the x power. And that was a graph that looked like this. Remember, there was an asymptote and all kinds of weird things. That was called an exponential. Notice it was 2 raised to the x power. In chapter 11, we're looking at the quadratic graph, and that is y equals x to the second power. And so our graph there will either look like an up U or it'll look like a down U, depending on what the coefficient is. But essentially, it's a U-shaped curve. It's a parabola. A parabola is a U-shaped curve. Okay, so you need to be very careful and have these clear in your mind. In chapter 10, this was called the exponential function or the exponential curve, and it looked sort of like this, and we had an asymptote, we had all kinds of fun stuff. Okay, for chapter 11, we're talking about the quadratic function or the quadratic graph. It's x to the second power as opposed to 2 to the x power. By simply changing the x's and the powers, everything changes. Everything changes. So you can't get these two confused, guys. They're totally different from each other. All right, it's 8:05. Let's take a 5-minute break. I'm out of water anyway. Let's take a 5-minute break, come back, and keep on working. We got a lot of stuff to do. So a 5-minute break. I know I said that the homework in chapter 11 is optional. I'm not going to collect it. I really, really encourage you to at least try some random problems, okay? Especially projectile motion problems. Huh? You know, that's the rocket is shot into the air. Okay. I try some of those. I'll keep trying to review these over the next couple of days. Okay. But you need more practice than what I can do just as a warm-up. On Mars, a rocket is launched into the air, whatever air there is, from a small hill. The height of the rocket is given by h of t equals negative 10 t squared plus 180 t plus 2000. Let's assume meters for height and seconds for time. Okay. First question. What is the maximum height the rocket reaches Second question, when does it crash into the ground? And let's round our answer to the nearest tenth. Okay. Projectile motion, rocket shot in the air, there's its formula. H of t stands for the height at some given time. When time is 0, it's at 2,000 meters. When time is 0, 0, 0, 2,000, it's at 2,000 meters. So the hill that it's being launched from is 2,000 feet high. From that hill, it goes up, okay? Now let's think about this for a second. I'm gonna have to erase this to make room for my work. So here's a hill and it's starting 2,000 meters above the ground level. Okay, starting at 2,000 meters above ground level. And then it goes up and comes back down and crashes into the ground. That's the basic thing. Now, a couple of things that we should begin to notice. First, if you look at this not as a word problem, not as a projectile motion, throwing something up and it comes down, but you said, oh, that's just a parabola because it's got t squared and t and blah, blah, blah. Okay. And its a value, the coefficient of the squared term, okay, is negative. It's a down parabola. And if you go back and look at all your notes from chapter 9, when we did all that projectile motion stuff, it was always negative something squared. And I always drew this picture because it made sense. Something goes up in the air and comes back down. Its natural path is a down parabola. Okay, So the first thing you need to know is recognize that, yeah, that's the shape of the parabola. The second thing, key word here, what is the maximum height that the rocket reaches? Well, the rocket's going to start at 2000 and it's going to go up somewhere, okay? And it's going to hit this maximum height here, max. It's going to hit a maximum height, okay? Guess what? That's the vertex. The maximum height in this picture is the vertex. So even though we didn't say vertex, based upon our notes from about 45 minutes ago or something like that, when you hit the maximum or the minimum, you're at the vertex. So all this is saying is find the vertex. It's saying a little bit more than that, but for us right now, that's all it's saying. Calculate the vertex, and then when does it crash into the ground? That's a different problem. So I'm going to turn off the recording and let you guys work on that. So I kind of guided you, and I said when it says find the maximum or the minimum, okay, other problems will ask you to find the minimum, assuming it's going down, okay? You're finding the vertex. So for this, we want the vertex, which remember the formula is negative b over 2a, comma, plug it in. So for us, we're going to go negative 180 over 2 times negative 10, comma, something, plug it in. So what's that? 9? Better check.
Yes.
Is it 9? Really?
Yes.
Okay. All right. If you say so. So now everybody's going to yell at you when we make a mistake. So 9, got to plug it in. So over on our calculator, we're doing negative 10 times 9 squared plus 180 times 9 plus 2000. Okay. Oops. I get 2,810. Okay, so that's my algebra. Can anybody confirm the 2,810 when I take 9 and plug it into this mess? I got 2,810. Can anybody confirm or not?
That's what I got.
That's what you got? Okay, good. Now, if you just said this, you're going to get the problem wrong. If you just said, oh, it's the vertex, yay, this is wrong. The question I said was, how high did it go? So you have to look at this answer and interpret it. What is it trying to tell you? Well, the 9 is in 9 seconds. Because this is a time axis. Time is measured instead of the x-axis, this is the time axis. So this is time. In 9 seconds, okay, this is the height. Or this is the y value. It went up this high, and that's height, or the y value. So your algebra, your arithmetic is correct. 9, 2,810. Yay. But what does it mean in context of this problem? How high? What's the height it goes? So if you tell me 9 comma 2,810, you're wrong because you're telling me you don't know the difference. That's how I'm interpreting it. But you would say the actual maximum height is 2,810 meters. Okay, the maximum height is 2,810 meters. Okay, so on the surface, no pun intended, this is an easy problem. The phrase or the word maximum implies vertex. So you find the vertex, but you can't just quit there. You got to think in this problem, what does the vertex mean? The first number is what we think of as x, but in this context, x is time. Time starts at 0 and goes forward. And what we used to think of as the y value is actually the height. Okay. As time goes forward, starting at 0 time, it'll be at 2,000 meters. As time goes forward, it'll go up higher, reach its max, and then come down. So that's the one thing I want to make sure you get on that problem is, number one, just plain how do you do it? And number two, how do you interpret your answer? Okay. There's a lot of critical thinking in there, a lot of critical thinking. All right, I'm going to be quiet right now while you finish this off, but when does it crash into the ground? What does that imply? When it's on the ground, when it hits the ground, bam, what fact do we know? Here's our formula. What's true when it hits the ground? Do we know the time? No, because when means find the time. Okay. Hitting the ground means height is 0. Height, Height, equals 0. So hitting the ground would be this equation here. 0 equals negative 10t squared plus 180t plus 2,000. Okay, that's the equation. I'm going to erase it while you guys are working and write it neater. But that's the equation for hitting the ground because the height will be 0 when it hits the ground. Okay, so I'll pause the recording. You solve the problem. I am recording. Okay. Notice the directions. I said, when does it crash into the ground? And I went through all this talking, blah, 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 about hitting the ground means height equals 0. So that's your equation. You solve it. Okay, whatever. You got some really ugly numbers here. Okay. But remember in the directions, I said, round your answer to the nearest tenth. Okay, round your answer to the nearest tenth. So that basically takes away all that fancy algebra. It just is saying, okay, use your calculator here. Don't worry about simplifying radicals and taking out perfect square roots and all that junk. Let your calculator do the work. That's what that's telling you. It actually is telling you, okay, that you can take as much shortcuts with the calculator as you can. So I got 112,400 for inside the radical. Okay, the radicand is what it was called. Can anybody confirm that? Did they get that also?
I got the same thing.
Okay, cool. So I haven't screwed up yet. Okay. Then I took the square root of this. So I have 180 plus or minus, and I got 335.2610923, all divided by 20. So I'm going to let my calculator do all that work. So there's two problems here. There's 180 plus this number, and then divide by 20. So this number plus 180 divided by 20. So I get 25.763, which rounds to 25.8, because I said round to the nearest tenth, and this is seconds. Okay, or if I do 180 minus this number, divided by 20, I get negative 7.76, whatever, 05, and this is a reject. Why? Because you can't have negative time. Negative time in this instance, okay, actually, scientifically, yes, you can have negative time, okay? But this problem says no. Remember, the rocket is taking off from here, going up and down, okay? It's taking off from this point. This is a 25.8 seconds out here when it hits the ground. The negative time is 7 seconds or 8 seconds, whatever you round to, before it took off. Your calculator doesn't understand that this is a rocket problem. It just says algebra. It says, oh, I've got a parabola, okay, and this over here is going to be negative 7.7 seconds, and this over here is going to be 25.7 seconds. Your calculator doesn't know what the heck you're doing. You, as an intelligent human, know, oh, negative time has to be rejected because it means prior to takeoff. By the way, has anybody ever watched or been to a rocket launch? You know, you see them on TV, T minus 5 seconds and counting, T minus. Well, when they're saying T minus 5, T minus 4, the minus means time before liftoff, time before ignition. So in terms of time, yeah, there can be negative time. It's before this, before now is considered negative time. Now is 0. Past now is positive time. But that's the philosophical idea. Anyway, for this problem, When does it hit the ground? Hits the ground at 25.8 seconds. So what you're going to find, and I will try to find time in the next few class meetings, but you need to go on your go on to mom and find some of these word problems. Okay. This is, oh, I should have told you, this is all 11.2. I forgot that. Dang it. All this stuff on parabolas, everything on parabolas that we're doing now is chapter 11.2. I screwed that one up. I'm sorry. Anyway, find some of those problems on mom. I'll try and find a few more as to act as warm-ups or problems we can do in class. I guarantee there will be a projectile motion where I ask you to find the maximum point and something like when does it hit the ground or when does it hit 1,000 feet or something like that. I guarantee that. And I will try and find more problems to help us practice that. All right, I need to erase this. We're still in chapter 11.2 and there's still so much to learn. Okay. Any questions about projectile motion? Same stuff we learned in chapter 9. We're just adding one little twist to it, and that is the maximum or minimum. And that's just simply another way of saying the vertex. Okay. Well, still in chapter 11.2. Okay. We talked about a quadratic function tonight as y equals ax squared plus bx plus c. And importantly, we talked about the vertex being negative b over 2a, comma, and then plug it in. Now, that's just something you have to know. That would be something I would make sure showed up on that 3x5 note card. However, there is another form of the quadratic function. It won't always look like this. Okay. Sometimes we use complete the square, CTS, okay, and I won't make you do that. I know in a Math 96 course, they will make you do this. I won't make you do this. Okay, we don't have enough time, okay? But sometimes they introduce the quadratic function as y equals a x minus h squared plus or minus k. Okay, so they use that magic completing the square stuff, you know, where you take half of the b value and all that nonsense or whatever. And it's not hard. It's just, I don't want to teach it now. You can transform this equation looking like this into this equation. Okay. What's nice about this equation is the vertex is h comma k. So when we give you an equation that looks like this, we're telling you what the vertex is, h comma whatever k is. Okay. And sometimes it's written differently, which I hate it when we do that, but we'll work with this one for now. Okay. Notice the h number is the opposite of what's inside the parenthesis, but the k number is whatever is the same. So this is the same. This is the opposite. So example. Suppose I asked you to graph y equals 2, x minus 3 squared plus I'm going to say 8 because I want to make it pretty. Okay, so suppose I said, hey, graph that one. Well, your vertex, well, actually, let's go with A. A is +2. That's the A value. It's the same A value as before, so that says it's going up. Okay, this is going up. A is a positive number, it's going up. My vertex, I don't have to use a negative b over 2a. I just have to remember the formula. It's 3, 8. So again, inside the parentheses, you see a -3, you use a +3. But the 8 is not inside a parenthesis. So you just use it as it is. If this had been a -8, okay, then you use a -8. So paying attention, if you're pulling information from inside of a parenthesis, you use the opposite of what you see. If you're just pulling information from the problem, the equation itself, you use exactly what you see. Okay. Now, the advantage of this format, or this equation here, is that you can pull the vertex out instantly. Very little thought. But the x-intercepts and the y-intercepts are hidden from you. So let's think about this. What if I said, what's the y-intercept? Well, that means x is 0. Y-intercept, x is 0. It was easy up here. I know some of you guys were probably out there rolling your eyes going, well, you idiot, the answer is C. Okay, but I was trying to show you that you plug 0 for x and do arithmetic. 0 plus 0 plus c equals c. It's not so easy here. The y-intercept means you do x is 0, so you have y equals 2 times 0, take away 3 squared, plus 8. So that's 2 times 9 plus 8. That's 18 plus 8, that's 26. So in this case, the y-intercept is 0, 26. It wasn't so easy. So you find the y-intercept by plugging 0 for x. And if it happens to be easy arithmetic, yay. But if it happens to be not quite so easy arithmetic, you just got to roll with it. Plug 0 for x, do your math work. Okay, well, we can still sketch this. Okay, it's not that bad. Where's my glare? There it is. Okay, 3, 8. Okay, here's my vertex. 8, sort of like here. Capital V, 3, 8. My y-intercept is way up here at 0, 26. My axis of symmetry is x equals 3, and its difference is 3 here. So we go over 3 here. Okay, so this will be 6, 26, and I can sketch the graph. And there's the graph. Okay, big drum roll. Does this have any x-intercepts?
No,
Because
it's going up.
going up. It's starting above the x-axis and it's going up. So it doesn't have any x-intercepts. I want to do the math for you to show you the algebra that you would get for the same thing. Because you're going to run into this, okay? You're going to run into this. So to find the x-intercepts, you set y equal to 0. So we have 0 equals 2 times, I'll get out of the way in a minute. So to find the x-intercepts, we take our y value and make it equal 0, and then we solve that problem. So the first thing I'm going to do is take away 8 from both sides. Then I'm going to divide both sides by 2. Okay, then I'm going to square root both sides. Remember that square root property? So I'm going to get plus or minus the square root of -4 equals x minus 3. Hang on, hang with me. This becomes plus or minus 2i. Remember, a negative inside of a square root means imaginary. 2i equals x minus 3. Add 3 to both sides. And we have a problem. Now, you could have quit a long time ago in this, but I want to show you something. X is an imaginary number. No problem. Actually, it's a complex number, but X is imaginary. Okay, no problem. Except when we're trying to graph. We can't graph imaginary numbers. So think about what we were doing. We were finding the x-intercept. But your algebra is trying to say, hey, dummy, wake up. Your x-intercept is imaginary. That's what it's trying to tell you. It doesn't exist. Okay, and that's what your graph actually says. Now, if I were to give you this problem and say, find the x-intercepts, you could, if you're aware enough, you could look at the sketch and you could say, it's impossible. It can't have x-intercepts because it's always above the x-axis. You could write me a little sentence and do no math. Okay, and that will get you full credit. Or you can start solving this. Now, I used the square root property. If you wanted to square everybody out and use the quad formula, that's your business. I don't care. Okay, but the minute you notice, uh-oh, I'm going to have imaginary answers. In a graph, we can't have imaginary answers. Okay, our graph is only real numbers. So the minute you're doing this work and you recognize, uh-oh, imaginary values, you can't have imaginary x-intercepts, you could quit and just say none. You don't have to work it all the way down to here. Now, if you do, cool. Okay, but the instant you see, oops, got a little issue here, got a problem, you can quit and just say there are no x-intercepts. But if you interpreted your graph correctly, you could do the same thing. Okay. So I've introduced for you a new form of quadratic function. Okay, that form, y equals a times x minus h quantity squared plus or minus k. The book probably won't write plus or minus k. I wrote it there to say that, to emphasize it could be positive, could be negative. You just use whatever it says. Then I worked through an example. First thing I did was figure out A. A was positive, means my sucker's going up. Yep, it's going up. Okay. Then I found the vertex. I found it by using HK. HK. Remember, I had to use that opposite trick. Then I found the y-intercept. That wasn't as easy as it was before. It was still arithmetic. It's not bad. It's still arithmetic, but it wasn't quite as easy as it was before. Okay, 0.26. I reflected it over the axis of symmetry. Over here, got this other answer. There's a pretty accurate graph. If I had graph paper and little dots, that would be more accurate, or at least as accurate as anybody with a calculator could give you. Okay, so there's my graph. Then I went off on this wild, crazy tangent about x-intercepts. This particular graph has none. You could see it in the picture, but even if you do the algebra, you're going to get imaginary answers, and we can't graph imaginary numbers. So we have imaginary x-intercepts, which basically means none. All right, I want to do another problem of these, but before I do, any questions? Okay. So let's go y equals -3, x minus, oops, come on, 2, come on, Foster, x minus 2 squared plus 9. Yeah. Let's make it plus 12. I want you guys to be semi-happy. Okay. So I want you to graph this. I want you to find the vertex, the x-intercepts, the y-intercepts, the axis of symmetry, and all that other junk. So let's pause, have you work through this. Okay, before I solve this, I want to talk about tomorrow night. Tomorrow on campus, we still have to complete chapter 11.2. I told you that 11.2 had everything in the world. What we haven't talked about, we've talked about up parabolas and down parabolas. Okay. What we haven't talked about is sideways parabolas, and we need to talk about them. So tomorrow night in chapter 11.2, okay, we're going to talk about parabolas that go sideways. Yikes. We're also going to talk, I can't remember what section it is, but whatever, about systems of equations. For example, we might have x plus y squared equals 3, and x squared minus 4y squared equals 11, and I want to solve that system. Okay, remember we used substitution, addition, elimination way back in chapter 4, I think it was. Okay, we're going to do that. And then we're going to talk about something called special triangles. Some of you may remember from high school, we had 45, 45, 90 triangles. Okay. Or some of you may remember we had 30, 60, 90 triangles. Okay, those are called special triangles. We're going to talk about them tomorrow. I'm pushing hard this week because I want to get everything as much done as possible so that on Tuesday and Wednesday of next week, and Lisi can do more on Monday, we can do nothing but review. We're going to have to do more, okay? Teach a little bit, but I want Tuesday and Wednesday to be a majority of review for you. I'm pushing hard now this week. Okay, tonight we covered a lot. Tomorrow night we're going to cover a lot more. Okay, pushing real hard so that you have time to let it sink in, time to try things over the weekend, so that Tuesday and Wednesday will be mostly review for next Thursday's test. And in the meantime, you're still studying for that final exam. So having said all of that, let's do this problem. A is -3, which means this problem is going down. Okay, the vertex is 2, 12. Okay, take the opposite of what we see inside 2, take exactly what we see outside 12. Okay, the y-intercept so we have y equals -3 times 0 minus 2 squared plus 12. So that's -3 times 4. 2 squared is 4 plus 12, which is 0. So my y-intercept is 0, 0. When x was 0, y turned out to be 0. Okay, let's see what that graph looks like. Okay, 2, 12, somewhere up here. Big V for vertex, 2, 12. Okay, the y-intercept is right there at 0, 0. I have an axis of symmetry that goes right down the middle. It's a dotted line. Its equation is x equals 2. So I can see that I have 2 units here. So I'm going to go over the same number of units. So this would be 4, 0. And now I can make a really accurate graph quite quickly. Whoops, that's too sloppy. Okay. Arrows, yes, arrows and everything. Now that's the basic graph. I still have to find the x-intercepts. But actually I found the x-intercepts. I got just dumb lucky on this, but I'm going to go through the algebra anyway. So any questions? A is -3. That's the A value right there. Tells me it's going down. Where did I get the vertex from? Are you okay with that? Just pulled it right out of this equation. Okay. My y-intercept meant set x equal to 0. So there's x is 0. So I just did arithmetic. Y turned out to be 0. So my x-intercept was 0, 0. I use the axis of symmetry to sketch that graph. I just happened to get dumb lucky, and my y-intercept happens to also be an x-intercept, and this reflection point happens to be the x-intercept. But I want to show you the math just in case you don't realize that. So to find the x-intercepts, we set y equal to 0. So I'll get out of the way. So this is the equation we're solving. To find the x-intercepts, we set y equal to 0 and solve this equation. So the first thing I'm going to do is subtract 12. Then I'm going to divide by -3. Then I'm going to use the square root property. So I'm going to square root both sides. But remember, that introduces a plus or minus into the problem. That was the trick in chapter 9. Go back and check that. But the square root of 4 is 2. So we have plus or minus 2 equals x minus 2. Add 2 to both sides. So we have 2 plus or minus 2. If you get that out, you get x equals 4 or 0 equals x, whatever. So you get the same answers I got here. Okay, I'm done. We covered a lot, went a little bit over tonight. It makes up for all the times we've gone home early. So see you all tomorrow. Bye.
Okay, thank you, Professor.
Thank you. Bye-bye.